Hello. Hi everyone. Welcome to Buildercast. I'm your host Arab Behel and I have a very special guest with me. Please welcome Karan Pareek. How are you today?
Hi Arab, I'm good. How are you doing?
All well. How is it going for you?
All good, just enjoying the weekend. Hectic work week usually ends in a relaxing weekend, so I'm just trying to make the most of it right now.
Right. Does like work ever sort of also push towards the weekends, or is there like a good work-life balance that way?
So I'm lucky that way that I have some sort of a work-life balance. Usually I don't have to work on the weekends, but every once in a while a request does pop in, something regarding research around a particular product or something. But usually it's all good.
The first thing that I actually wanted to ask you was how did you actually find this intersection of music and AI? Because it's something that I would say is very niche and not a lot of people know about the intersection of these two things. So I'd love to know about how you just got started with it.
Sure. So the start of my music and AI journey is somewhat interesting. So I don't have a typical academic curve, right? So I was a commerce student in school, then I was an economics student in my undergrad, and then I went for my postgrad in music technology at NYU, right? So one of the core courses there was on digital signal processing
Mhm.
because the main subject that we had to study was music technology, right? And that digital signal processing course had a bunch of stuff about electrical engineering concepts, right? Stuff like filtering and audio processing and how do you kind of manipulate audio for feature extraction and all these things. So I got into coding because of that, and a byproduct of that was that I ended up taking a lot of different courses related to coding, and I completed my thesis in 3D and immersive audio. So I did a lot of things related to coding, but none related to AI up until
Mhm.
then. So it was my last semester, and this whole AI and ML concept was kind of like floating around. So a lot of
What year
kids
is
in
this?
this age is 2019.
Okay. So AIM is
2019.
just about getting cool.
Yeah, AIML, yeah, just all the cool kids are just trying to like join in.
Right.
And the over AIML has been there for a long time, but I wanted to basically take a course in machine learning, but that course was in the engineering school, and I was afraid that I was luckily for me I was like a straight A student up until then, so I was scared that if I take that course I'll kind of plummet my GPA down a little bit. But luckily it was the last semester, so I was kind of I was not sure whether I should do it or not. So, in lieu of that, NYU usually offers a course. It's called an independent study, wherein you get in touch with the professor and you complete a project with them. So, I got in touch with the professor who was writing a research paper on machine learning. So, I got in touch with him and I introduced myself. I told him my background, and he said that, listen, you don't know anything about machine learning. Here are some things that you should read up on. I'm going to see you in 2 weeks. This is the code base for a project that I'm working on. Come back in 2 weeks and explain what's going on. They were the most terrible 2 weeks of my life. I could barely sleep. I was just going to strange parts of the internet, mostly on Reddit, and trying to figure out what all this stuff was. And I couldn't understand anything, right? Because my first introduction to machine learning was basically deep learning, right? So machine learning is divided into two parts, more or less, or AI. AI is somewhat like a blanket term. So the first part is traditional machine learning, and the other part is deep learning, right? Where all your LLMs and your neural networks are formed. So this was a neural network project, and spent basically the entirety of 2 weeks trying to figure out what was going on. And in the end, I got an idea as to how these things work, right? So that was my first introduction into what the actual power of this technology was. And eventually, the next 2, 3 months was the entire duration of the project. So I helped the professor out with writing that research paper, conducting some experiments. So that's how my AI journey began.
That's I think what I find really fascinating about that was it could have actually gone two ways. You either could have completely enjoyed that experience and the 2 weeks of grinding on AI, or you could have ended up like I completely hate this thing. I never want to look at this again. But
Yeah, I
I'm
agree.
glad it went the former way.
Yeah, I mean, I wanted to eventually learn it. So I like to, do some challenging things. Like I mentioned, my academic curve is somewhat strange. So I kind of took it up on as a challenge, and I wanted to, grind through it and figure out what was going on. And luckily for me, there was actually another PhD student working with me on that, and he was a machine learning expert. So he helped me a lot trying to understand the nuances of what was going on.
Right, but you already knew all the math requirements. It was more of the coding stuff that was difficult for you.
So yeah, so I knew most of the math actually. So in fact, all of machine learning is basically matrices,
Correct.
right? Everything
Linear
is
algebra.
matrix multiplication. It's just
Yeah.
linear algebra, and I learned linear algebra in school as well as college, right? So I knew all the math. The nuances are basically related to structures, right? So I'll just give you a simple example. So um, there was a an array of models called convolutional neural networks that was really really popular in the 2010s, right? And convolutional neural networks are a set of models that work primarily with images, basically two-dimensional data. And what they do is, let's say you have a 28 by 28 pixel image, and you want to understand whether it's a cat or a dog. So you input that image into your network. So it does this matrix multiplication, kind of like array by array, and it keeps shrinking the image down. So you start with a 28 by 28 image, then you maybe go down to a 15 by 15, and then you do some operation, then you go down to a 5 by 5, right? So you've kind of condensed the image down into 25 data points from 768 points,
Hmm.
and then you do some processing, and then you figure out, okay, is it a cat or a dog? So all of these components are done using matrix multiplication. You have something called a kernel size, you have hop size and everything, right? So all of these nuances were somewhat new to me, and I had some trouble initially, kind of wrapping my head around how these things work, right? And I think the second difficulty here was, first was of course the structure, but I think the second one, which I somewhat struggle with even up until now, is the intuition. And I'm sure we'll talk about LLMs, very very soon. So a lot of these complex neural networks, these complex AI architectures, they have some sort of intuition behind them. So it's very hard to initially understand. It's very hard to initially look at these structures and understand what that intuition is. So I just described you what the CNNs are, right? And if you look at it maybe from a slightly intuitive angle, you'll see that, achha, okay, if I have a 28 by 28 image, that's a really big image. The dog could be maybe in one side of the input. Maybe the dog, envelopes the entire image, right? So the dog can be anywhere, the cat can be anywhere. So I need to shrink down and look at a certain part of the image and then just get a summary of what that part is, right? So let's assume that we have an image and the dog is maybe on the bottom right. So how do you figure out that the dog is at the bottom right? So you'll start looking at the image from the top left, and then you'll scan everything. So you've already made a summary of what is there on the top row. Is there a dog? No. Then you'll start looking in the middle of the image, and then you'll make a summary, and then you'll probably see the head of the dog on the middle row rightmost column, and you'll be like, I can see some ears, maybe the dog is right here. And then you'll scan the bottom row, and then you'll eventually come to the bottom row right column, and then you'll see the body of the dog. So you've kind of made these summaries, right? And how have you made these summaries? You've gone through the 28 by 28 image, and then you maybe shrunk it down in your head to maybe a 15 by 15. You shrunk it down to 5 by 5, right? So you've taken that big image, and then you said, okay, no dog, no dog, no, 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 yes, right? So instead of 28 by 28, you have just a 3 by 3 answer of how you looked at the image, right? So that's just a very intuitive way of seeing what these networks do. And these intuitive explanations just get more and more interesting and more tougher to understand. And we'll obviously talk a little bit about it, and, attention, because LLMs is like the new thing. But yeah, I think I'll let you ask the next question.
No, but I'm now fascinated by CNNs because I've not really worked with CNNs that much.
Hmm.
And if we were to like just take this to the context of let's say somebody's never worked with CNNs before, and you would just want to explain, what the essence of a CNN is and what the application of CNNs really looks like in your workflow. How would you explain that to somebody who's never worked with them before?
So that's a good question. And so CNNs are basically a class of models that primarily work with two-dimensional or multi-dimensional data. So I'm just going to leave text on the side because there is a whole host of models for text, but primarily for images and audio as well. Right? We're recording this podcast. Your voice is being recorded through a microphone. That audio source could be either mono or stereo, right? So mono is just a single channel. Stereo is all of the music that you basically listen to, right? Which is basically two channels. There's a left speaker and a right speaker. So anything, so in this case, it is multidimensional, right? And CNNs are really good, like I said, at breaking down the input into smaller segments and understanding what the nuance of each segment is. To explain the essence of CNNs better, I'll give you another example. So there's a very famous example in CNNs that kind of deals with understanding what CNNs understand, right? There was a very famous paper called AlexNet that came out maybe 2014, 2016. It was by this PhD researcher, and he was working on classification of images, right? So CNNs were somewhat popular then on classification of images, but into not cat or dog, but into, 3,000 or 4,000 buckets. So if I show you an image, it can be a ship, it can be a cat, it can be a tree, it can be anything, right? So as you kind of scale the problem up to, instead of a cat and dog, if you scale that up to, 5,000 buckets, the problem gets exponentially hard, right? So one of the outcomes of that paper as well was an understanding into what does a CNN actually look at in an image. There's a very interesting, maybe you can look it up later. There's a very interesting, set of images and a set, actually a set of plots that show the first few layers of a CNN will look at all of the horizontal lines, and the next few layers of a CNN will look at all the vertical lines, right? So this is called salience, salient features. Go from a 28 by 28 image. If you just plot it, you'll see a picture of a cat. But if you plot the 15 by 15 grid, you'll probably see just a bunch of horizontal lines. And you'll be like, okay, wait, that doesn't look anything like a cat. Of course, it's not supposed to look like a cat because it's in the hidden part of the CNN, right? And then you kind of go further and then you'll see that, okay, and I'm only seeing vertical lines. And then you keep going deeper, then you'll start seeing curves, right? So when you plot all of these things adjacent to each other, you get an understanding that the CNN is actually breaking down the image, or in this case, breaking down any multi-dimensional data into some sort of features. And they could be maybe a directional feature, or maybe they are multi-dimensional features in the sense that they have a certain, maybe a wave in the case of audio, specific things that they're trying to understand, right? So coming back to your question as to how I would explain it, so I would probably choose this approach that when you are trying to work with multidimensional data, CNNs look at breaking down the problem, breaking down your input into segments, segmentation. Segmentation as a word is actually used for another sort of AI problems, but let's assume that segmentation is a word wherein you are segmenting your input into multiple parts, and you're kind of getting an understanding of what each of these segments actually means and what these quote unquote features. So I'll start calling them features from now on, right? So what each of these features actually look like.
Okay, very interesting. And I can actually share my screen so that people
Sure.
can understand what you were saying about you said salient features, if I'm not wrong, right?
Yes. So salient features and images.
Let me just quickly share it. Maybe is is this like remotely related to what you were talking about?
So if you look at if you go to this image, general structure of neural networks, the one on the right with the face of the man, right?
Okay.
Yeah, if you just click on this image, or if you just zoom into it, and if you just zoom in, see, you can start seeing that in the first layer, right? Where the, so if you go to the face of the man,
Mm-hmm.
that is your input. And as you go on to the first layer, let's just disregard what the name of the layer is. Let's just call it layer one, right? You can start seeing some sort of a pattern. So there's a black and white pattern, right? But the
Mm-hmm.
black and white pattern is uh, is more apparent in the sense that it's more blocky. And by blocky, I mean when you have a black pattern, it's taking a lot of the space. When you have a white pattern, it's taking a lot of the space. So it's consistent. But as soon as you go to layer number two, it starts getting a little fuzzy because it's starting to look at certain specific features, right? So maybe layer one is actually looking at where is the nose, right? So if you look at my face, the area where my nose is will probably turn white because the activation, right? In this case, maybe a number between 0 and 1. The numbers are 1 all throughout here, but it's all 0 everywhere else. But it's not one, like, it's not a precise one over here. It's trying to understand that, okay, maybe the nose is in this general direction. It's definitely not here or here. And as you start going deeper, if you look at layer number three, it looks like a bunch of mush, but it's trying to look at certain more nuanced things, right? So if you can you zoom in really close on the third image, right? Maybe it's not super clear, but as you can see, the white and the black portions are starting to resemble more maybe something like a face or something that resembles a part of the face, right?
Right. Mm-hmm.
So these are basically features, right? So as you keep going deeper into the network, and by deeper I mean the more layers that you process your input through, your input becomes more and more, quote unquote, convoluted and harder to understand. But as you start plotting these, you can start understanding that depending on your task, depending on whatever your task is, you can look at these features and maybe try and understand the part of the image that they're trying to address.
I think that actually makes it so much more interesting, and I see the familiar softmax function here as well,
Yes.
which I've seen in other papers as well, and maybe we'll get into softmax slightly later. But is there any element of probability distribution here? Because he said that that nose is probably somewhere around here. It's definitely not here or here. Does it also use some element of like probability distributions to say that it's probably somewhere around here, but probability of it being here is like super remote or something?
Yeah. So that's a really deep question. You know, I mean, it's a really large question to answer, but
Okay.
maybe I can kind of start from one place, right? So each output of the layer of any of these layers is some number, right? So it's some floating point number. Maybe it's 20.9, maybe it's, minus 0.7 or something. We don't know what the number is. Uh, we don't care what the number is. What we care in this case is the number, let's say, positive or negative? So there's something called an activation function. What an activation function does is that it after you've processed your layer, it will generate something. What it generates, we don't really care. We want to bound that output, right? We want to say that, acha, okay, I want all numbers between 1 and minus 1, for example. So in the case of audio, right? So all audio signals are between 1 and minus 1. All images are only have positive pixels. There are no negative pixels. So if I get an output of my layer, if there is a negative number, should I keep it or not? Probably not, because pixels cannot be negative. So I will add this activation function, right? So the most popular activation function used as part of images, it's called ReLU. What that does is that if it's just a function f of x that says if x is greater than 0, then it's x. If x is less than equal to 0, it's 0. right? So it's just
Okay.
zero for all negative numbers, obviously including zero because zero just remains zero, and it's positive for, which is x, for all numbers greater than zero. So what starts happening here is that you start, as the network starts to learn, you are bounding the output of each of these layers so that towards the end you just get a bunch of positive numbers. Are they probabilistic in nature? I'm not entirely sure, right? But they represent the features that you want to highlight, right? Now, the probabilistic aspect actually starts happening towards the end, which was, the familiar softmax layer that you had mentioned.
Mm-hmm.
So the softmax layer in this case takes a bunch of these numbers and says that, okay, if this array of numbers is supposed to represent uh, an array of probabilities, it's just a function that says that, okay, convert all of these numbers that is, this large in range to between 0 and 1. It's not exactly between 0 and 1 in the sense that it's not just, you're dividing by the min and multiplying by 1 or dividing by the max to kind of squish it down. It's a non-linear function, so it's called a non-linear activation function. So softmax is also an activation function. Your ReLU is a linear activation function because there's no quadratic term, right? It's just x or 0. So you add this non-linearity activation function, and then you get a bunch of probabilities, right? So in the image that we saw, it was trying to classify the face of the man into some sort of emotion, right? Whether it's anger, disgust, neutral, happy, sad. So in that case, if you remember, the face of the man was pretty neutral. So after applying the activation function, which is softmax, it converts it into a bunch of probabilities, and it says that it's okay, its neutral pay, it's the highest, right? So
Mm.
it's 9, probably, 0.9 on neutral, but it's zero point 0.7 on sad, right? So the network will say that, okay, it's probably neutral because the highest probability that my model is outputting is for neutral. So the output should probably be neutral.
That makes a lot of sense. Very interesting that the way that people have actually come up with these neural network layers, because essentially the one that's most used now is transformers, but the evolution of just these,
Yeah.
I think, neural networks has been so interesting to see.
Yeah. In fact, anyone who's actually getting into I would recommend that don't jump, one should not jump into LLMs and, all of these complex architectures. I think convolution neural networks are probably the best place to start because, they harbor so many aspects of intuition and so many kind of these, these crazy things that, that we can actually do. And it's such a great and simple way of understanding the overall flow of how these networks actually work, right? So, just to kind of digress just a little bit, when you are trying to train a neural network, right? So you get some sort of a loss function, right? So you say that it's okay, it was actually sad, but the reality was that the face of the man actually displayed a neutral emotion. So it's going to do something called back propagation. So it's going to send a correction signal throughout the network. And when you study CNNs, it's very, very easy to figure out how your correction signal is flowing in the chain and how these weights are getting updated, right? So I love CNNs. I think they're really cool. Uh, they're still used in a bunch of places, but unfortunately, the transformer architecture has taken over. But anyone who's starting to get into AI and trying to understand all these architectures, I think CNN is a fantastic place to start.
Is there like a specific flow of architectures that you'd actually recommend to people, that maybe start off with CNNs and then move on to RNNs maybe? So is there like a specific flow before you actually get to transformers today?
Yeah, so the textbook way, that all these textbooks usually say CNNs and then RNNs and then LSTMs and
Okay.
bidirectional LSTMs and what else structures are there? Maybe like encoders, bidirectional vanilla encoders, auto encoders, and then you kind of get onto more complex stuff, right? So you can certainly follow. There's a reason why RNNs are a little more complicated than CNNs. because they just have a lot more nuances. They have stuff like gating, and they have some softmax function in the beginning. They have sigmoid functions for gates and then activations and that. So there's a bunch of kind of complicated stuff, and RNNs have their own challenges. But I think CNNs are that are at that absolute sweet spot wherein you can actually train your own CNN very conveniently, get great results, and be in a position wherein you understand how these things actually work.
Very cool. So I think I'm probably going to jump from CNN directly to Transformers because I think it's just a lot more fun, right? Because you feel like you're actually like I love that Karpathy video wherein he just actually makes like a GPT from scratch, because then he also explains the transformer architecture, and then you feel like you're actually training like your own mini LLM. And for that case, it's specifically like a Shakespearean set, but you could just use
Yeah,
your own and go wild with it.
yeah. Transformers are crazy, and the story of Transformers also actually pretty interesting. So the Transformer architecture was actually made for a task called sequence to sequence translation, right? So researchers at Google were trying to say that, okay, if we have a language, let's say we have English, and we want to convert or translate the language into French, how do we do it? So this problem was originally actually solved using LSTMs, but the main problem about LSTMs, so there were two main problems about LSTMs, right? So the first problem was that training these LSTMs is notoriously hard. They suffer from, in fact, RNNs suffer from this a lot more, LSTMs much less. But the whole the whole gamut of sequence models all suffer from something called vanishing gradients. And what I mean by vanishing gradients is that let's say you're just multiplying a bunch of large numbers together, right? 100 times 100 times 100 is going to give you a very large number, right? But if you multiply smaller numbers, let's say 0.1 times 0.9 plus 0.99 plus 0.9999, like no matter how large it is, you are going to start getting decreasing values, right? So the kind of divergence that you see, right? And so this is just a way of explaining what these vanishing gradients are. So as you kind of back propagate through the model, the size of the weights becomes so small that eventually all of the numbers that you're multiplying are essentially going down to zero. So the signal of improvement that you get using back propagation is ultimately zero at the beginning of the model. Why it's at the beginning is because you're kind of going from the output to the beginning. So by the time it reaches the first layer, the value is just so small that the tuning that the first few layers of the model does is basically minuscule. So the signal just isn't as strong, right? Now, when you do the second issue was stuff related to receptive field, right? So a receptive field is the amount of information that you can input into the model at once. So when you have a sequence to sequence model, so let's say we have a receptive field of maybe 10 words. Right? So you can only look at 10 words. And if I was to translate a large paragraph of English into French, so since I can only take 10 words at the beginning, I can only translate these 10 words. And then I have to maybe do a skip, or either I go, full 10 words ahead, or maybe I do like a sliding window wherein I just keep translating, and then maybe I have some sort of algorithm that combines these words at the end. But I also risk losing information because maybe there is a sentence in English that says, this is a cat, and I'm translating this is a, and then I'm translating is a cat. But it could be that in French, this is a and is a cat actually translates into slightly different words, right? Wherein it's maybe word number ABC in French, but instead of being BCD, right? Wherein is the cat, instead of is being BCD, maybe it's maybe some XCD, right? But right, so that intersection of words could actually translate into multiple words. So I'm and and this is just an example that we risk losing information because of a smaller receptive field. So Transformers attacks this in a very nice and intuitive way. and intuitive, and by intuitive I mean intuitive with a grain of salt, because it gets a little more complicated in the structure. But how they do it is that they were essentially trying to solve this problem, right? They were saying that it's okay, we have to translate an English sentence into French. Now, another issue, one main issue that we have with translation tasks is that the number of words used in a sentence in one language, which is English, may not be the same number of words that you use in the other language. So if I say, good morning, sir, in French, that's bonjour, uh, monsieur. So if I
The
say
French
good
classes are
morning,
coming.
yes, the French are coming in handy. So if I say good morning, that is just one word in French, which is bonjour, right? That's not two words. It's not like bon and jour, right? It's just one word. Though that kind of does make sense. Bon, that translates to good day, but I don't know why that exists. So in this case, if you see good morning, sir, is three words, but in French, it's two words. So you can't really equate two words with three words, right? So how do you kind of
Hmm.
translate that information, right? So
Right.
what what Transformers wanted to do was tackle this situation exactly. And what they realized is that if you have a matrix, right, wherein you have good morning, sir, on one side, and if you have bonjour, monsieur, on one side, I'm skipping a little ahead, but your attention for good morning should, that signal of attention should be really high with bonjour, and the attention of sir should have a really high attention with monsieur, right? So as you look at these several examples, you start seeing a pattern, right? So you start thinking in a way that, acha, okay, maybe a combination of words in one language is one single word in the other language, or a combination of, or maybe one single language in English is actually multiple words in French, right? So I think a classic example could be the word 80. So in English, 80 is 80, but in French, 80 is 80. Why is it 80? Nobody knows, right? 80 is just 420, which is, I don't know why it's 420, right? So in English it's just 80, but in French it's 80. So we've established the same problem, but in the other direction, wherein we are going from one word to two words. So in
Hmm.
this case, if you think about it, the attention between, if I say good morning, sir, it's your total is 20. It translates to bonjour, monsieur, blah, 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 80, right? So 20, a single word, should have a very high attention with 80, and the same for the first few words that we described, right? So when you approach your problem from this perspective, you start realizing that instead of doing a sequence to sequence translation, wherein I input a bunch of words and I just get one string of words and I just get a string of words, maybe I should look at the problem by, instead of doing one is to one, maybe I should invert the problem and start looking at how each of these words actually relate to each of these words, right? And how can I look at the relation of these words? Maybe I can do a bunch of smart maths, right? And so begins the era of transformation, of transformers, right? Wherein they looked at the input and then they equated the input with itself. And they said that, okay, and my intuitive understanding of transformers is that they are doing something, the way I look at it is that they're basically doing an autocorrelation, right? They're just taking input and they're saying what part of my sentence is the most important to me, given some output, right? So if I do maybe some sort of smart math and I say that it's okay, this is ka signal is very high and my output may, the signal for bonjour is very high, even though this isn't bonjour is actually incorrect. My lost signal will propagate in such a way wherein the attention or the signal that I have, dedicated to this is will suddenly go down and maybe some other few words will crop up, right? So just to kind of, again, TLDR here, attention, what Transformers was trying to attack was essentially the sequence to sequence paper, right? So if you read the original attention is all you need paper, you will not see any other examples related to LLMs. It's just for sequence to sequence translations, wherein they understood the problem that some dimensional data in one input does not necessarily relate to the same dimensionality in the output. So is there a neat way to combine my input and maybe transform it somewhere, transform it into some input wherein it fits very neatly with my output, right? So that's the intuitive understanding of what transformers are and how they kind of began. Of course, now it's just a bunch of mess, right? People have taken some architecture and they're just kind of running free with it. But I hope you understand, I hope you kind of get an intuitive understanding of what is the problem that they were trying to solve and how it kind of catapulted into what we have today.
I think I think my understanding is definitely improved, but there are still a few questions that I would have here. Uh, the first one is, could you just also simplify the word attention? Because you said that this word, it's being paid more attention to. So what does that also intuitively mean to you when you say that there is more attention on this word?
Okay, so the structure of the transformer is kind of divided into multiple parts, right? So there's an input that you have. You go through something called positional embedding, which is just a fancy way of saying my input is a bunch of text. I want to convert it into numbers. So please go ahead and convert it into numbers, right? So now that I have some numbers, right? Then the main portion of the transformer is something called multi-headed self-attention. We will break that down into its parts in just a second, right? Now, after all that fancy business is done, we will pass it to some sort of a neural simple feed-forward layer, right? And we will get some output, right? So I'm not going to explain the latter. Uh, I'm not going to explain the. Going to focus on the middle part, right? Which is multi-headed self-attention. Multi-headed simply means that there are multiple versions of something happening, right? So it's just saying, it's the same way of saying 10x attention, self-attention, or self-attention x. So it's just multiple versions of something called a head in which my transformations are happening. And what is the transformation that is happening? One of the transformation that is happening is something called self-attention, right? So self-attention basically means the following. So let us say that I have some input and let's say I have a sentence and I give that sentence to three people. And those three people have to work together to understand what that sentence means, or maybe convert it into some jumble that I understand. So let's assume that we're in the middle of a world war and I have three cryptographers with me. I send them a secret message and they are supposed to look at that message and work in some way and then generate an output that I understand and maybe my recipient understands. How they work is as follows, right? So it's divided into three people. There's something called query, key, and value. So query key value means that you are the first person. What it does is that it multiplies your input with some numbers that it understands. So the first person does something, the second person does something, and the third person does something, right? So it's, or in the middle, the second and the third person does something combined, right? So the output basically becomes some array of numbers that I understand, that I know how to process, right? So this is basically the self-attention part, right? So what is there in self-attention? It's just three entities that are working together to transform the input, and they do the same thing multiple times, right? And what they do, I will just explain. But remember, we had multi-headed self-attention. So let's assume that these three people, I have an exact clone of these three people 10 times, right? And each of these three people and by clone, I means a slightly different clone. So let's say I pick a 12th grader from Delhi, a 12th grader from Calcutta, 12th grader from Mumbai. Now, all of these three are 12th graders, but their life experiences and everything is different. Everybody, all three of them know and understand English. All three of them know that my sentence is, this is a cat. But their intuitive explanation of, or maybe the way they function their life, their understanding of that sentence is slightly different. So I've taken multiple versions of the student, or multiple versions of that entity multiple times, right? So it's multi-headed. And the three of these people from Delhi, Bombay, and Calcutta, for example, are doing a bunch of stuff. And in the end, I'm collecting all of their understanding and then I'm processing it, right? So what are they doing, right? So they're doing a bunch of matrix multiplication. Now, why does that matrix multiplication actually help me? And what are they trying to do? Like, are they trying to condense something down? Are they trying to tell me that, okay, maybe you shouldn't read this part of the sentence, maybe this part is important, right? Which brings us to the concept of attention, right? So the same input is I'm sending to three sets of people, of three people each, and each set of people will look at the sentence and tell me what part of the sentence they think is important. So the first person will say that this, the word this is very important because it articulates, the fact that we're talking about a specific thing. Maybe my question was, what is the article in this? So it's like, okay, this is a very important word. Now the second bunch of people will say that this is very important. And the third one says cat is important. Okay, so I have these three versions of this understanding. And why it's called self attention is because it's doing the thing on the input itself, right? So I'm not introducing any new novel thing from the outside. I'm just telling it, okay, this is your sentence. Up, you can reverse it, you can change a bunch of things, but this is all the information that you have, right? So we took three different groups, multi-headed. We took three people, query key value. We told them to do a bunch of things on them, and they generated an output. And that output is some two-dimensional matrix that tells me what part of the sentence do I think is important. And that importance metric is called attention. So when I plot the attention layers for a given input for an LLM prompt, there will be certain parts of the matrix that will light up, and there are certain parts of the matrix that will not light up. Classic example is a summarization task, right? So if you have a summarization task, and if I give you a long list of maybe like 100-word paragraph, and I tell you that, okay, you are supposed to summarize this down into 20 words, right? So you will start, let's say the paragraph is about, I don't know, let's say the Big Ben. So the Big Ben is located in London, blah, 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 right?
Hmm.
So because of how the network has learned, based on its training data and all, it'll see that, okay, Big Ben, London, UK, clock, time, tourist attraction, monument, all of these things will have a lot of attention because that is the understanding that the word Big Ben has. So it's able to put the attention towards Big Ben, and it says that, okay, Big Ben as an entity or as an input based on my training data, I'm supposed to focus my attention on stuff like clock, monument, UK, and London, and not focus on, maybe words like the, is a, short, many, right? It doesn't really make sense. What is the essence of Big Ben? It's all of these words, right? So you're providing attention by amping up the signal. And how is the signal amped up? When we have multiple people, which is multi-headed, multiple groups of people, where each group is query, key, and value, and they're doing a bunch of stuff in the middle, and they're giving me an out. I hope that makes sense.
I think that makes sense. I think I had some understanding because I watched like three blue one browns video and just
Yes.
some other stuff on YouTube. So that I think allowed me to follow it in a better way. But I think this actually goes beyond that in some ways. So that was super useful. Okay, let's go on
It's
to some easy
yeah,
questions now, and then
sure.
we'll circle back to LLMs. So, what was like your typical day in the life as somebody who was doing first like AI research?
So a typical day usually starts off with the overarching problem at hand, right? So I can give you an example. My first job, my first professional, full-time job was at a startup in the US. Right, they're still doing some amazing work. They're called Modulate.ai. Please do check them out. They're doing some great work.
Yeah, they've raised 30 mil, right?
Sorry?
I think they've raised 30 million.
Yeah, they raised a Series A in 2022. Yeah, I think
Okay.
sometime in July or August 2022. Yeah, so they're doing really well. They're doing a bunch of crazy stuff. Um, there, we had a very interesting problem. We were trying to do voice to voice translation, right? So you could sound like me in real time, let's say on your podcast, or you could maybe
Oh,
sound like
damn.
Anil Kapoor on your podcast. It's a really cool
Right.
technology, right? So when you kind of show up to work with that big of a problem to solve, you have to start breaking down the problem into, a bunch of things, right? So each day you walk into the office, your task is like, okay, maybe I'm supposed to analyze a particular data set, right? Maybe you've done some predictions using a machine learning model. You are going to use your data science tools, some statistical tools to maybe plot some distributions, maybe get an understanding of what my output distribution looks like. Am I going to do some statistical testing on them? Do I have reason to believe that N% of my inputs were above a particular threshold, so on and so forth, right? So you're doing all these data science things. Other than that, you're also just generally brainstorming and thinking about the problem, right? What are some other ways that you can tackle these problems? Is there any existing research on them? We have people try to solve this thing. You are also spending a lot of your time reading research papers, understanding what is out there. If not the same problem, then have people solved similar problems, right? Any machine learning problem can be broken down into multiple things. Let's say if I am doing a problem, let's say wherein I'm making some sort of like a podcast website, and I have all of these videos, and I'm supposed to classify these videos into a bunch of playlists, right?
Hmm.
So can apply different types of machine learnings. Maybe it's based on the content. Maybe it's like all AI podcasts go into one folder, all science related podcasts go into one folder, all tech related podcasts go into one folder. And how would I do that? I will do that by doing tech stuff. So I'll start saying that it's okay. Text classification, text summarization, meeting summarization models out there. So I'll use them. But maybe I also want to do, maybe do it by the name of the podcaster. So let's say, you form a collab with someone else, and the both of your fellow colleague and you run this podcast together, and you want to create a playlist wherein it's Araf's podcast and it's Mr. X's podcast, right? So now it's a different problem, right? So now you're not looking at the text necessarily. You are now looking at, let's say, the face of the podcaster. So you're
Hmm.
saying that, okay, this is what RF looks like. I
This is
need to
what,
use
yeah.
an image classification model to ensure that my playlist contains RF in one playlist and Mr. X in the other playlist. Or I can maybe do a voice classification saying, this is what RF sounds like. Maybe I can use speaker diarization and say, this is what RF's voice is. So create a playlist separately for RF and Mr. X, right? So it just depends on how you to solve that problem, right? Maybe you want to do both of them. So you'll start breaking a problem down further and you'll be like, okay, I will create two playlists. Any new person who comes onto my website can either search by the keyword, or maybe they can search by the name of the podcaster. Let's say, your mother comes in and she is with a bunch of relatives, and she says, I want to show off my son's podcast list. So she will search Arav, right? And all of Arav's podcasts will show up where Arav is the host, right? So now if you kind of take it back to like what happens during the day, right? So there are multiple ways of solving the same problem, right? Is there one singular way of solving the problem? Maybe not, right? So you are reading a lot of these research papers and trying to figure out what is out there. Have people tried to solve a similar problem? What are the data sets that they're using? Are there any open source models that I can try out?
Very interesting. And what are the hours like?
So the hours are relatively good actually. So, my current job is, from 9:30 to maybe 6:37. So I have a decent work-life balance. My
Hmm.
previous jobs are also pretty forgiving in that manner, right? The hours are not super long, but because you're using so much of your brain trying to read all
Right.
of these things and trying to like think how I can solve the problem, it's actually pretty taxing, right? So one does tend to get pretty tired by the end of the day.
Fair enough. I think it's also because you're working on hard problems, right? It's not PowerPoints that you're making.
Yeah, these are definitely hard problems, and not to, and not to put any other job profile down, right? I
Fair
think this
enough.
is
I
a
shouldn't. I should not have said that.
no, no, that's okay. But, it's just a different type of job profile. It requires you to think about the problem in a different way. Lawyers, for example, my wife is a lawyer, so her hours are crazy long. She has a very different type of work, right? So she has very long hours, but she also has a lot of hours where she has to use maybe the right side of the brain for creativity. Again, don't quote me on this. I don't know which one is the creative side, which one is the worker side, but maybe she has to put a lot of her creative mind to it also, because how can we interpret the law? But maybe she's using the other part of the brain the other times, right? Which is about condensing of information, reading a bunch of documents, right? So it's not necessarily about the number of hours that you're working. I think it's the quality of the work that you do.
Fair enough. Have you told her about Harvey? Like, can they use that at work, really?
Harvey?
Yeah, it's like a very popular legal AI LLM thing.
Harvey is
Yeah. Have you seen Harvey?
Harvey. I believe, yeah, I think I did take a look. I think the last time when we spoke over phone, we
Yeah, yeah,
had,
yeah. I think we discussed it because I'm not really sure like whether like these multi big corporates have they started onboarding, or is it like more of the smaller lawyers using it. But they
yeah,
do say on their website that their legal teams, the KKR and a bunch of the other
mm,
ones have been using it. But I would be really excited if they
yeah,
actually just start implementing this at like a team wide level where everybody gets access to something like this.
yeah. And in fact, there is a very, very interesting Indian counterpart to this as well. I discovered this about 2 weeks ago. So, and you
Hmm.
should definitely check it out. This thing is called Sarvam.ai.
Oh yeah, of
So,
course.
yeah, so it's an initiative, I think, by a professor of IIT Madras. So they recently
Right.
got funding, I think, some $40 million or something.
Mhm.
So
Yeah, yeah.
one of their products in that is using legal LLMs, right? So I did
Okay.
get a chance to speak about that with my wife as well. And
Hmm.
it just goes to show that even a field, like the legal field wherein everything is so confidential, LLMs are basically an untapped potential because you have so much of text data, and you should be working with LLMs basically sooner than late.
Yeah, yeah, I think I agree. I think it's like very, it's, I think the last time we were discussing this, we were talking about how vertical integration is probably the way to go because Chat
Yeah,
GPT and all the other ones are perhaps very good at just the horizontal side of things. But if you actually want to create value, going vertical just means that you just focus on one specific industry or domain. So you work with, let's say, a specific type of data, just solve that problem really really well, so you just are optimizing in a way to solve that problem. So like Harvey and a bunch of these other ones, like I know a tool which just focuses on research papers. So
mm,
you make your tool in such a way that you're really really good at that one task, because for the wide majority of things most people would probably be better suited with ChatGPT or Claude Sonnet 3.5 if you're coding or something. But I think vertical integration is probably one good way to do it. And Server May, I think one of their main things was also they were working on like indigenous models wherein they were very focused on Indian languages and
yeah,
having models that were trained on our data and on our languages. So I was in Bangalore 2 months back. So I met a couple of people from Sarvam, and all of them were like very optimistic, and they had like this good purpose about their work. So that was pretty good. It's like the most talked about startup in Bangalore right now, I think.
yeah. It's really crazy. So there are a bunch of AI initiatives for the Indian context. So there's one by the government of India actually. It's called Bhashini,
Mm-hmm.
right? And they have teamed up with and again an IIT Madras initiative. Sorry, it's called AI for Bharat, right?
Yeah, okay. It's the
So,
same. It's the same person, I think.
I think it's the same.
Uh,
If not the same person, then I think it's the same circle of research. Maybe
Okay.
one is from Triple IT Hyderabad, maybe one is from IIT Madras.
Mm-hmm.
Again, I'm not sure, but it's basically the same research circle, right? So they're all working on
Right.
Indic languages. And I'm really happy to see so much of deep work going on into Indic languages because, the use of in India I'm predicting that the use of AI in India is going to explode. And the biggest barrier is English, basically, right? Or in
Mm-hmm.
most of these LLMs are trained in English, right? They have a lot of English training data. They have some other multilingual data as well, obviously, because they can converse fluently in Spanish and French and all that stuff. But indigenous language data, especially from India, right? What we call Indic languages, is very, very low, right? So these are called low resource languages. So if we are having, again, which brings us very neatly to the whole vertical perspective, right? Is that if you have an LLM, what if I maybe fine tune it or tune it to understand just Bangla, for example? Do current LLMs understand and converse in Bangla? Absolutely. GPT does that very well. Llama does that very well. But can they understand Bangla fluently and converse with the user in Bangla impeccably? Maybe not. It's going to break somewhere in the middle, right? So if I train it on just Bangla data, I am transforming my search from the whole horizontal aspect to the vertical aspect. And then maybe I can start using this Bangla LLM to, make further advancements in the AI tools that require the Bangla language as input, right? Maybe I need to build, let's say, an AI startup that is connected with all hotels. Again, if anybody wants to work on that, they can just ping me. I'd be more than happy to help. But let's say for hotel reservations, right? So many people call the concierge for saying that, or in fact, so many people go to their hotel room and they pick up the phone and press zero, right? And usually a help desk person picks up like, hi, welcome to the help desk. How may I help you? Hi, I'm calling from room 306. I need shampoo. Okay, sir, let me just connect you to housekeeping. Toot. You go to housekeeping. Hello, sir. I'm calling from 306. I need some shampoo. Okay, sir, you'll get shampoo. Right? Now imagine if the same thing. Okay, this is actually a really cool idea. Imagine the same thing was in English, right? Or using AI. You press zero. Hello, sir, how may I help you? I'm calling from 306. Can I know what your concern is? Or if I'm saying, हाँ जी सर मैं आपकी क्या समस्या है मुझे शैम्पू चाहिए सर प्लीज वेट करिए मैं आपको हाउसकीपिंग पे कनेक्ट करती हूँ अगेन एन ऑटोमेटेड बॉट हाँ जी सर कहाँ से बोल रहे हैं 306 से सर आप 306 से बोल रहे हैं हाँ जी 306 से बोल रहा हूँ मुझे शैम्पू चाहिए एंड it kind of all kind of lines up. This is a really cool idea. I think I should work on it, but
I think yeah, so I think the best implication of actually something like that is at the just the customer service level. So if you
yeah,
just have a product out in the market, right, and you just get so many of these customer calls, and you're always somehow doubtful that are these customers being served properly, are all of their issues being resolved. So actually I met a couple of guys at a hackathon who were working on this, and they said that if we're able to like make this scale properly, we can have like 3,000 concurrent calls, and you don't
oh
really
yeah,
need people as well, right? So you can just have an AI that's properly trained on your Indic languages, and you can just then make it so much more accessible to everyone. I was also looking at these just like farmers also. So farmers, it's not really accessible AI really for them, because you do need some level of English proficiency today if you're a farmer and you just want to learn about, well, how can I perhaps use this. So I think for it to be actually very accessible to people in India, Indic languages becomes so important, because otherwise you're just alienating such a big section of your population. But I think where a lot of them struggle is, how do we come up with the data sets? Is it that we get our own people and we just get them up and running ourselves? Is it available? Like, what do you think about the data training aspect?
yeah. That's actually a big challenge, especially for these low resource languages.
Mm-hmm.
So, for Bharat, they came out with their paper. I think it was last year they had published their paper in ACL,
Mm-hmm.
which is the top NLP conference in the world, right? So again, I don't exactly remember how they collected their data, But after going through the pages of Bhashini, right, which is the Government of India initiative,
Mm-hmm.
they actually deployed vendors all across India and they paid them well, and they went to all of these different states, all the way from major cities to these remote villages, and then they recorded what they were saying, and then
Mm-hmm.
they transcribed it as well, right? So because, for example, I don't understand Bangla, so it doesn't make sense for me to go to, for me to go to Calcutta and hear someone what they're saying and then transcribe it, right? But I need a subject matter expert in this case who understands the language well, right? For them to go and listen to what people are saying, record them, and then transcribe them, right? Transcribe what they're saying. So they basically deployed all of these subject matter experts all throughout the country.
Hmm.
There are 28 official languages in India, so at least 28 sets of people were required, right?
Right.
But it's a big initiative, right? And they managed to collect basically a crazy amount of data, and I believe it's publicly available as well currently.
The data sets
Which,
as well.
yeah, from what
Oh,
I
that'd
know, I
be
think they're current. Yeah, which
okay.
is really cool because
Correct.
what this harbors is the whole era of open source stuff, right? I know, which
Correct.
I'm a big fan of, right? Which is
Yeah.
when you're open sourcing all of these things, the advancements that you will see in your research is manifold, right? So if tomorrow someone wants to do this, make this bot, right, the hotel bot, for example, concierge bot for, let's say, the Taj group, right? They have all of this data, they just need to train an LLM model, make an IVR situation. Again, it's not as simple, but they can certainly do this really quickly, and then they can get it up and running, right? If all of this data was not available, and if all these Indic languages, models were not available, it would be a monumental task, right? Because where do you even find all this data from? I think another resource is, just to complete my thought, is there's a initiative by Mozilla, right, which is
Mm-hmm.
the Firefox one, a
Yeah.
very very large data set that they maintain. It's called Common Voice.
Okay.
So they basically collect data from everyday people. So if you go to their website called Mozilla or commonvoice.org, you can just select the language that you want to talk in. You can just read the text and say it out loud, right? So you are basically contributing your own voice. So they do it.
Okay.
They've done it at scale. They've obviously published the website for everyone to use. So,
Hmm.
from time to time, you can just choose your language. You can just submit your data, and it's a publicly available data set, right? Which is really cool because you know we have people contributing to these large data sets, and as more and more people contribute to these large data sets, these machines become better, they become more efficient, right? They become so much better at understanding what we're saying, how we're saying it, right? So it's kind of like a circle, right? Like you have to offer a helping hand to be able to get a helping hand in return when you require one.
Yeah, and when you mention open source is so cool, I just remember the fact that the original paper, right, that actually just started all of this, attention is all you need, was written by Google researchers, if I'm not wrong. So, had that paper perhaps not been open source and it would have just been closed source, you might have, maybe not seen ChatGPT at all to begin with, because GPT-3 was essentially, just based on the transformer architecture. Had that not been open source, we could have been living in a very different world today, and maybe you would have just had Gemini, because only Google would have had the IP of the transformer architecture.
Yeah, it's very interesting to see that, right? Like, I've been reading a lot about, open sourcing technologies and you know, how the world is shifting and how the
Mm-hmm.
world is changing because of these open source technologies. And I think a classical example is that, what if, right? The whole paradigm of what if creeps up. Like, what if we had never open sourced any of these technologies? What if, all these big, large corporations were money hungry and didn't want to, distribute this, IP to the world and maybe just generate in-house technology. And I think a very classic example of this is, recommendation engines, right? So Netflix has its own recommendation engine. It's a really cool recommendation engine. But Amazon Prime also has its recommendation engine. Will they share their IP with each other? Probably never, right? But will they share the structure of their recommendation engines so that eventual recommendations engines get better? Absolutely, right? And there's a very, and I read this article a couple of weeks ago, which draws a really nice parallel
Mhm.
to how the world works, right? I was talking about open sourcing, right? And they draw a very nice parallel. So the article basically says that, and it kind of diverges, digresses into a different direction. It says, why is there evil in the world? There is evil in the world so that, and why is there disease in the world? There's disease in the world so that the doctors and the people who are helping out keep becoming better at the job that they do. Why do variants of diseases keep coming up?
Mhm.
Because we've already solved the first variant. We've already learned how to cure the first variant.
Mhm.
These diseases keep coming up, the evil keeps popping up to make the good side of the world better, right? So if you think about it from the open source perspective, why are we open sourcing this technology? So that everybody uses it. And when
Mhm.
everybody uses it, someone will use it for malintent. And when someone uses it for malintent, we'll understand how to make our security systems better. We'll understand how to install better guardrails on these LLMs and this new AI technology. You have to open source also to be able to understand what the power of the technology is and how you can make it better. If this technology, maybe if Llama was not open source, for example, right? Maybe we would not have the paper that, so 1 or 2 days ago, I think yesterday or the day before yesterday, the latest open source paper came out, which is called Reflection, which is
Mhm.
the strongest open source performing paper, right? You can check it out. I think 2 days ago it came out. They just fine-tuned Llama. So if Llama was an open source, we wouldn't have been getting models like this, right? So again, they draw a very cool parallel to how the world works and why we actually need to open source technology to get better technology in the future.
Now, that's actually so interesting because it's like a different way of thinking about
Yeah,
just technology at large, right? That the reason that there is bad is so that I think like one case of that is also the fact that so that the good also continue to do good stuff because there are like repercussions for doing bad stuff in a way,
yeah,
but also so that you learn from what the bad ways of doing stuff is. Because I was just I think listening to a podcast with where Ilya was there, and he just raised $1 billion with SSI, which is Safe
yeah.
Super Intelligence.
Intelligence.
And it's wild, right? Like, how do you randomly just wake up and I saw that they raised 1 billion with this, and that was like the first time that I actually seen that they were starting it. But the weird thing was I wasn't even surprised. Like I was like, yeah, I mean, makes sense. Stellar team, everything stellar. Like it makes sense that they were able to raise $1 billion, but that's like the wild world we live in. That
Yeah,
it's just, it's like it doesn't blow my mind now that somebody just raised $1 billion.
yeah. Especially with stuff like AI, I think AI is not selling like hotcakes anymore. The person selling the hotcakes and the industry that's making the hotcakes and the people consuming the hotcakes are all AI. So everybody is like basically the whole buzz is AI is not just a buzzword anymore. AI is the buzz basically, right? It's the
Mm-hmm.
main thing people are focusing on, and of course it has an immense amount of potential, and it has to be obviously used very, it has to be used properly, right? Because it can kind of go in the opposite direction really quickly, or or to not be that macabre. I think it can give a not so comfortable experience as well, right? Because when you go and maybe chat with a person about, let's say if your credit card gets stolen, right? If you're talking to a person, the person might sympathize with you, right? They'll be like, "I'm sorry to hear that's, you don't have to worry. We're here for you. Can you please confirm your details? Where were you last? Like, what was the last transaction that you made? So on and so forth, right? But an AI would probably be a little more cold, be like, okay, no sorry, no apologies, nothing. They'll just probably talk like
Yeah.
that. Right? So we also risk having an uncomfortable experience rather than a bad experience. I would like to think that AI will do a lot more good for the world than bad.
Yeah, I think that's a good thought for sure. Like, I think we should all just be eternal optimists because it's just a happier way to live.
Absolutely, absolutely.
One of the sort of last questions that I want to ask you is, it just sort of blows my mind that the way that the LM architecture works is that your words have like some 12,000 dimensions, right? Because
Yeah.
essentially they're all just vectors. So when you just have a word, you just trying to convert these to integers, and you have like 12,000 dimensions with that vector. And like till now in calculus 3 or in any of my other high modules also, we perhaps go to 3 dimensions or at maximum 4. So that's like where my that's how much I can understand. I can't even comprehend like what does 12,000 dimensions look like. So are like researchers able to comprehend what that looks like, or like what is it?
So that's a good question, and I have wondered about the same thing as well. I think the general consensus on this is that by dimension, we mean the size of something, right?
Mm-hmm.
So when we say an embedding is has 512 dimensions,
Mm-hmm.
it is a vector of size 1 by 512, which
Okay.
is 512 numbers. So we're
Right.
not doing any, interstellar warping stuff by
Right.
getting going to the 512th dimension. I
Okay.
think the general consensus is that, and again, I've thought about this quite deeply, it's just the length of something, right? So when you have a 1000 dimension vector in
Hmm.
the embedding space, uh, and just to give you a quick example, let's say you have 10,000 words की vocabulary, and
Correct.
your embedding dimension is 100. So you're not
Hmm.
doing some interstellar meta stuff where you're like
Hmm.
doing some crazy, like, light speed stuff. All you're saying is if you choose any of the 10,000 words, right? If there is a word, let's say, dog, right? So the word dog will be represented by a bunch of numbers, and the length of these numbers, the number of numbers or the dimension of the embedding is 1000 or 1024.
Hmm.
That's essentially what they're trying to say, right? So it's not, unfortunately, it's
It's
not
not
as cool
dimension. It's
as,
just collection of numbers
it's
that we can
just a
think.
collection number. Unfortunately, it's not as cool as doing string theory, but that's what they mean by embedding, right? So it's not some, like I said, not some meta, light speed
Yeah.
ahead
Yeah.
stuff. I think it's just a very fancy way of saying that if I select any given word, the length of my embedding, the shape of my embedding is n dimensions longer, is n numbers long.
Yeah. I think that makes me feel a lot more at ease, because the person who would have thought about, if it would have been 1,000 dimensions, you have to be like super cracked to even think about something like that. But I think if it's just a collection of numbers, then I can still
Yeah,
sympathize with the fact that okay, like you can perhaps think of this at least.
absolutely.
Okay. Cool. I think those are most of my questions. Thank you so much, Karan. This was like really, really fun. I really enjoyed asking you a lot of these questions. And I hope, I mean, we both of us try to make it accessible to like more people, so that even if you don't know a lot about AI, you're still able to follow and understand more of the most of the stuff. And I think Karan was like very kind to just simplify as much stuff as he could, and you could like see him just breaking down each and every word that he was saying, because there's just so much complex jargon out there. But I think this would have like really helped a lot of people. So thank you so much, Karan, for taking out the time to do this.
Yeah, thanks all. Thanks for having me. It was my pirate podcast, and I was a little nervous in the beginning, but I'm happy to come on this podcast once again, maybe sometime later, talk about something entirely different, and I'm really, I think what really excites me right now are, I know you didn't ask me, but I'm still going to say this. I think what really excites me nowadays is, apart from the technology that is AI, I think the most exciting part also is the ethics, right? Because technology today, right, the AI technology today is powerful enough that people are beginning to use it in their everyday life. It's powerful enough that countries are now understanding that okay, this is an actual thing that we can use. So the overarching ethics and the overarching rules and regulations is something that really kind of excites me. Like, how are countries thinking of it? How is the world thinking of embracing this technology, knowing that this thing actually works now? It's not just a sham, right?
Right. Yeah, I think AI ethics. will probably be a really big thing in the future. And I think it's a very good intersection of like a little bit of technology, but you also just get the opportunity to have like really large impact, because what you'll actually be working on can determine, I mean, not to sound like very macro about this, but it could like very well impact the future of the human race and the way that we're able to
Yeah,
utilize AI, because it's like one of the more fundamental questions that we'll have to answer, considering you got like this AI race going on and everybody's trying to get to AGI. So the more regulation we have around it, I'm not really sure whether regulation is for the better, but just a lot of government sector employees, and there need to be people in the government who understand AI as well. And I
yeah,
think AI ethics can really, really help with that.
absolutely. Yeah, yeah. Thanks for having me over, Arav.
Cool.
It was
Is there
it was a lot of fun.
anything else that you'd want to discuss? Any questions for me? Anything that you
I
want
think
to
that's
add?
about it. I'm used to interviews. I'm used to attending interviews and saying, "No, sir, I don't have any more questions." I think this was a little bit of a refresher. But
Okay.
yeah, unfortunately, no questions from my end. I think my heartiest congratulations on your podcast, right? And I I hope you succeed in this thing. I and of course it was an absolute pleasure being here and talking about all this technology that I usually talk and bore my friends with. So, and I'm glad to have received undivided attention for the last 1.5 hours, right? So so I really appreciate it, Arav. Thank you so much for having me over.
Okay. Thank you so much.